All right, so we've talked about the rules of exponents. We've talked about rational exponents, so let's put that information to use now to look at exponential functions and the graph of exponential functions. So we have here two examples, f of x equals 2 to the x power and f of x equals 1/2 to the x power. I know that plugging in numbers here for x, if I do 2 to the 0 power, that equals 1. 2 to the first equals 2. 2 squared equals 4. 2 to the third equals 8. 2 to the negative 1 means take the reciprocal of 2, 1 over 2. 2 to the negative 2 means the reciprocal of 1 over 2, reciprocal of that, so it's 1 over 2 squared, 1/4. 2 to the negative 3, 1 over 2 to the third, 1/8. When I graph those, negative 3, I'm at 1/8, negative 2, 1/4, negative 1, 1/2, 0, 1, 1, 2, 2, 4, 3, 8. And if I continue this, I know that it's going to just keep getting closer and closer to this x-axis, to the left, and then just sweep up really quickly here to the right. Alright, f of x equals 1/2 to the x power. Again, to the 0, 1/2 to the 0 power is equal to 1. 1/2 to the first power is 1/2. 1/2 squared is 1/4. 1/2 to the third is 1/8. If I do 1/2 to the negative 1, I take the reciprocal, which is 2 to the first, or just 2. If I do 1/2 to the negative 2, I take the reciprocal, which is 2, and I square it. 2 squared is 4. And 1/2 to the negative 3 is 2 cubed, which is 8. So at negative 3, I'm at 8. At negative 2, I'm at 4. Negative 1, I'm at 2. 0, 1, 1, 1/2, 2, 1/4, 3, 1/8. So this one is sweeping down very quickly. And as I head to the right, it gets closer and closer to the x-axis. Okay, so let's fill in the bottom down here. Domain for both of these, all real numbers. Should put an arrow on there. All real numbers from negative infinity to positive infinity. All real numbers, interval notation, negative infinity to positive infinity. The range, my y values, I never touch the x-axis, I never go below the x-axis, so this will be from 0 to infinity non-inclusive. 0 to infinity non-inclusive. In other words, in inequality notation, y is greater than 0. On this one, it is increasing over its entire existence. From negative infinity to positive infinity, it is increasing. This one is always decreasing from negative infinity to positive infinity. For the first graph, as x approaches infinity, as I go to the right, f of x is going to positive infinity as well. As I go to the left, as f of x approaches negative infinity, heading to the left, f of x is approaching 0. So that tells me I have a horizontal asymptote at y equals 0. The other one, as x approaches infinity, my f of x is approaching 0. I'm getting closer and closer to 0 as I go to the right. As I head to the left, as I go negative infinity, f of x approaches positive infinity. So again, I have a horizontal asymptote at y equals 0. Okay, next page. Exponential functions are functions of the form f of x equals b to the x power, where b is a positive number, has to be greater than 0, and b cannot be equal to 1. If b is greater than 1, then we have an increasing function. F of x is always increasing. If b is between 0 and 1, then f of x is decreasing. So, we're first going to look at the case where b is greater than 1, where we get these increasing functions here. So graph f of x equals b to the x power for b greater than 1. And for our graphing purposes here, we're going to use the example of f of x equals 2 to the x, which is what we just graphed a minute ago. So I know, I'm just going to put in a couple values here. At -1, I get 1/2. At 0, I get 1. For 1, I get 2. For 2, I get 4. For 3, I get 8. So 0, 1, 1, 2, 2, 4, 3, 8, and 1/2. And then we're going to go through here. And there we go. F of x equals 2 to the x power. Domain, all real numbers. The range, y greater than 0, not equal to, excuse me, y greater than 0. Asymptote, got a horizontal asymptote at y equals 0. Oops, sorry about that. I was going off the page here. All right, y greater, so we said all real numbers, y greater than 0, y equals 0 is the asymptote. Characteristics then. This is a one-to-one function. It passes the horizontal line test. It is always increasing on its entire existence. On the interval from -infinity to +infinity, it is increasing. There is no x-intercept. Never touches the x-axis. And there is a y-intercept at 0, 1. In general, all exponential functions of this type will go through the point 0, 1. They always go through 0, 1, and also they're going to go through the point 1b. So if I'm looking at just the general equation y equals b to the x power, it will go through 0, 1. It will also go through the point 1b, whatever the value of b is. In our case here, it was 2. Okay? Okay. Second situation is when b is between 0 and 1. It's less than 1, but it's greater than 0. It has to be a positive number. So it's between 0 and 1. And again, we're going to use for graphing purposes, we're going to use that 1/2 x like we had on the front. So just plugging in some numbers here. If I put in -3, -2, -1, 0, and 1, I know I'm going to get 8, 4, 2, 1, and 1/2. My domain, all real numbers. My range is going to be y greater than 0. And we'll have an asymptote at y equals 0. At -3, I'm at 8. At -2, I'm at 4. -1, I'm at 2. 0, 1. 1, 1/2. And this is just going to follow that x-axis to the right. Characteristics. This also is a one-to-one function. This one is decreasing over its entire existence from -infinity to +infinity. Once again, there is no x-intercept. And once again, the y-intercept is 0, 1. And also, it goes through that point 1b, in this case 1, 1/2, which I have right here. All right.